Welcome back to the Awesome Agents podcast. Today we are talking about vLLM version 0.17, and honestly, this one is packed.
It really is. When I saw the release notes, I had to slow down and actually read them because there's a lot going on beneath the headline.
So for folks who don't know, vLLM is the inference engine a huge chunk of the AI world runs on. What dropped in this version?
The biggest headline is FlashAttention 4 integration, and the timing here is kind of wild. FlashAttention 4 itself was published on March 5th, and vLLM had it in production 2 days later.
2 days? That's fast. How does that even happen?
It reflects how active the contributor community is. This release had 699 commits from 272 contributors, and 48 of those were first-time contributors. That's not a small team moving slowly.
Okay, so what does FlashAttention 4 actually do, like in plain language?
So it's an attention algorithm designed specifically for NVIDIA's new Blackwell chips. The B200 GPU has a lot more raw compute than the previous H100, but the memory bandwidth and some other units didn't scale up at the same rate.
So the chip got faster in some ways, but not evenly.
Exactly. And FlashAttention 4 uses a technique called ping-pong scheduling to keep both compute pipelines busy at the same time instead of one waiting on the other.
And the numbers?
On a B200, they're hitting 1,605 TeraLLPs per second with 71% hardware use. Compare that to about 600 from FlashAttention 3 on the older H100 hardware.
So roughly 2.7x faster?
2.7x over Triton implementations, yes. And about 1.1 to 1.3x better than CUDNN 9.13, which is striking because CUDNN is NVIDIA's own highly tuned library.
That's a serious number. Does this help people who aren't running the newest, most expensive Blackwell hardware?
It does help on older Hopper hardware like H100 and H200, just less dramatically. The main benefit there is actually compile time. FA4 cuts it by 20 to 30 times compared to earlier versions.
Okay, so let's talk about the other big feature because I think this one is actually more consequential for production teams, the Elastic Expert parallelism thing.
Yes, this is the one I'd tell a production engineer to read carefully. So MoE models, mixture of experts models, spread their computation across multiple GPUs. And until now, if you wanted to change how many GPUs you were using, you had to stop the server, reconfigure, and restart.
Which means drop requests, service interruptions.
All of that. So what Milestone 2 of Elastic Expert Parallelism adds is the ability to rescale live. You can add GPUs during a traffic spike or remove them when load drops, and the routing adjusts in the background without taking the endpoint offline.
How does it actually do that without disrupting in-flight requests?
There are two pieces. One is an async rebalancer that monitors per expert token load and moves cold experts to newly added workers. Hot experts stay pinned to avoid unnecessary data shuffling. The second is a sync layer using NCCL that commits the new routing table only once all workers agree on it.
So there's still some coordination overhead.
There is, and the team is upfront about it. Under high load, a rebalance event will create a brief latency spike. It's a known limitation and it's listed in their RFC. So this is real and useful, but you should test it under load before trusting it for auto-scaling.
Fair. Not it works perfectly, more like it works and here's what to watch for.
Exactly, which I actually appreciate. They're not overselling it.
Let's talk about the new performance mode flag because I thought that was a nice touch for operators.
Yeah, it's a quality of life thing. You can now start vLLM with a flag set to balanced, interactivity, or throughput. Interactivity minimizes time to first token for chat use cases. Throughput maximizes batch processing for offline workloads. Balanced is the default.
So instead of having to know which internal scheduler parameters to tweak, you just pick a mode.
Right, it's a sensible abstraction. Most operators know what they're building. If it's a chat app, pick interactivity. If it's running overnight batch jobs, pick throughput.
There's also new model support in this release, Quinn 3.5 in particular.
Full stack support for the QN 3.5 family, including FP8 quantization, and something new which is real-time audio streaming for speech recognition. The ASR path runs audio through chunked preprocessing and then into the same batching engine as text.
So you can handle audio and text requests on the same server?
Same server, same GPU capacity without running separate processes for each. That's actually a meaningful operational simplification if you're building a product that handles both.
What about the hardware coverage beyond NVIDIA?
This release adds real work on AMD ROKM, Intel XPU, and ARM-based CPUs. The Intel XPU editions in particular reflect genuine production demand from enterprise teams that need alternatives to NVIDIA for cost or compliance reasons.
Okay, let's be balanced here. What doesn't work well in this release?
The PyTorch 2.1 upgrade is the main friction point. If you just run pip install upgrade vLLM, things will break unless you update PyTorch separately first. And there's an edge case with CUDA 12.9 where you can hit errors that require removing system CUDA from the library path.
So the upgrade path is a bit rough.
It's manageable, but it's not clean. And the performance gains they advertise are real but narrow. The 13.9% throughput improvement applies to pooling models specifically, not a general chat endpoint running Llama.
Good to know. Read the fine print before expecting those numbers.
Exactly. The benchmarks are honest but specific. Match them to your actual workload.
So for someone following vLLM, what is the key thing to take away from this release?
The combination of FA4 for Blackwell and live elastic parallelism for MoE models together moves this closer to something you could actually build reliable infrastructure on. But the upgrade requires hands-on work that the release notes make sound easier than it is.
Test before you deploy to production, basically.
Always, but especially here.
That's the Awesome Agents podcast. Find the full article with code examples and benchmarks at awesomeagents.ai. We'll see you next time.